and today we'll be going over infrastructure as code on AWS, specifically how to use CloudFormation to build out Chef Server 12 and automatically bootstrap clients into that Chef server. So before I get started on the slides here, I'm going to kick over to a shell and actually start a build live of Chef Server 12. And I'll explain during the slides what I'm doing here in a minute. Okay. So it doesn't take a genius to figure out that if you're going to be successful in the cloud, you really need to automate your infrastructure. So how do we automate our infrastructure successfully? On AWS, there's several different ways, but let's talk about infrastructure as code first. So what do we mean by infrastructure as code? So I like to think of it as a way to enable the reconstruction of the entire business from a source code repository, an application data backup, and the bare metal resources needed to restore everything. The primary constraint in these situations should be the amount of time it takes you to restore your data, not how long it takes you to actually rebuild your entire infrastructure. So on AWS, we have a tool called CloudFormation. It enables you to be able to create infrastructure as code systems. So CloudFormation gives developers and system administrators easy ways to create and manage collections of related AWS resources, provisioning and updating them in an orderly and predictable fashion. It was first released in 2010, so it's about 5 years old now. It's a very mature product, very stable. Some of the things you can do with CloudFormation, it integrates very well with version control, so you can tie this into your Git systems, etc. It's really just JSON formatted documents. These documents form templates that you can use for repeatable infrastructure to create stacks of resources that support any AWS resource type. So these documents can then be placed under version control, or like I'm going to do at the end of this presentation, you can share these documents so that you can actually share your entire application. So at the end, I'll be giving out a GitHub repo link, and you'll be able to download the files that I'm using today to create the Chef server live. These CloudFormation templates enable you to create the repeatable, reliable deployments, not only for testing, but also for dev and for production use in any AWS region. So I'm not going to go over all the resource types, but we'll highlight a few of these. If you're not familiar with it, IAM, which is a requirement for running the templates that we'll be going over today, is our identity and access management service. This not only enables you to create things like users and groups, but specifically what I'll be using for these templates is a feature called roles. These enable servers to run with permissions like you would for a user, but you don't have to embed the access keys on the server, so it's more secure. Things like EC2, of course, Elastic Beanstalk, S3 for storage, and of course RDS for our database services. So your entire application can be represented in AWS with a CloudFormation template. These templates can then be checked into your version control system to track any changes. And then you can use these templates to redeploy the same environments for dev, test, and production. So what we have going on here is an AWS account that has a VPC. Inside the VPC, we have several different CloudFormation stacks. All of these different boxes were defined and built with CloudFormation. So here we have, for instance, some different test environments. We have an RDS. We have a testing environment here with a continuous integration server. We have a NAT instance, SQS, S3, etc. So for the example that I'm going to go through today, the one that's running in the background, before I started and used these templates, I created in the console 2 roles. One I set up for the Chef server I called DevOps, and I gave it administrator access so that it could be able to create buckets and be able to manipulate the AWS APIs with the AWS CLI command. I also created another role for S3 access to be used by the clients that will automatically bootstrap into the Chef server. That's a more restricted role that only allows these clients to be able to read from the S3 bucket that's created by the Chef server template. So let's dive into the code and see what we're doing here in the background. So here's an example of the CloudFormation template that I'm currently using. It's building Chef Server 12. So we'll start out going over some of the parameter sections here. Of course, we've got a template version and description that tells us what we're doing with the template. And then we ask for some input parameters. These could be either specified through the console or these could be fed in through the CLI. I'm going to ask for a key name for SSH, an instance type, which by default I have set for M3 large. And I've got different allowed values here. These you would need to change if you reuse these templates and need access to other instance types. So for this example, I have the ability to spin up instances that are T2 or M3 instance types. Next, I defined the chef server role input parameter, and this is the role that I had pre-created in the console, or I could have used CloudFormation to pre-create. Source location. For this demo example, since I'm on a public address here, I'm not going to define an IP address range to lock it down to, but if you do decide to go home and reuse any of these templates, I highly encourage that you lock down the management interface to the source IP of your home modem, your office IP networks, whatever environment that you're working in. We'll move into the mappings next. This is what tells us what AMI to run for the instance. For this example, I'm only going to work in US East 1, so I've only defined one AMI here. If you Google this AMI, you'll find that it's a RHEL 6.5 AMI. So if you try and use it, be sure that you've launched at least one Red Hat instance before. There may be a click-through through the agreement that you have to do in order to launch the Red Hat instances. So what does it look like when we actually stand up the instance? So there's an AWS EC2 instance type that we'll define. And one of the examples I wanted to give was how to create a file on the instance before user data runs. So what we have here is a metadata section where we can define config files that we're going to create first. In this example, I'm creating a root.aws config file that will be used by the AWS CLI command that will be installed later. This config file tells the AWS CLI which region that it's going to be working in. Specifically, in this case, we're defaulting to the region US East 1. This file then has the following permissions where it's read-only by root. So moving into our properties section, this is where you'll see the security groups defined. The IAM instance profile, this is what passes in for the role so that it knows what role to run as. In this case, I was passing in a DevOps parameter, so it's running with those permissions. And then we define our image ID, and then the magic happens actually here in the user data section. So first I define some path information that will be needed, and then I set up something called a chef server wait handle here. This is going to cause a wait condition to be set up for CloudFormation interaction so that when these things are created and started, the console doesn't show it completed while scripts are still running on the server installing. What will happen is at the very end, when all my scripts are finished installing Chef Server 12 and it's completed, then we'll signal back to CloudFormation, a CFN signal that says that we're done, and it'll know that processing is completed. Further down, we'll go ahead and actually bootstrap Chef Server here. And for this, I did a very simple technique where I pulled down from S3 using wget, a simple installation shell script that I wrote, and then I chmod it, executable, and simply execute it. And the shell script does all the magic inside the user data instance to actually install the RPM and configure Chef, add a user. It installs, for instance, the web module that you can use free for up to 10 hosts. And it also configures the certificate that will be needed to use, the certificate that is needed to automatically bootstrap clients in the second phase when we plug in and use the client CloudFormation template. Since Red Hat does not automatically include the AWS CLI like the Amazon Linux instances do, I went ahead and installed the AWS CLI here. It's very simple. We did a curl for pip, and then we used pip to install AWS CLI. And then finally, we are at the point in the user data section where our script install Chef Server is completed. We've got the AWS CLI installed, so that we simply use the AWS CLI command to copy up the certificate that we need to a secure S3 bucket that we'll define further below in the template. And that command is AWS S3 CP, and then we copy the chefvalidator.pim up into that bucket. And if everything went correctly, we didn't have any failures, everything worked correctly with our scripts, then we've made it to this section of this user data where we will now signal CloudFormation that we've completed and that we can release the wait handle and move on. Moving on, I've got the Chef security group defined next. This Chef security group opens up SSH and web access to the Chef server. In this case, I'm opening up ports 22 and 443, and I've got this set up so that port 22 and 443 would be restricted to that source IP location that you can pass in the beginning as an input parameter. In my case here for the example, that's just wide open as 000. And then also it allows the Chef client security group to connect to the Chef server inside of AWS. So here's how we define the Chef client security group. For this example, working through this, I wanted to be able to SSH directly in to each one of my development client nodes so that I could check for any failures as I was working through the client installation script. So I have port 22 open so that I can SSH into those. And then also I had port 80 open as I was playing around with installing Apache and just checking, making sure I had connectivity to those instances. Next, we define our Chef key bucket, which is the private S3 bucket that we'll use to upload our certificate PIM into. And one of the great things about CloudFormation is that it's going to automatically append a unique string to the end of our bucket name so that we can rerun these same templates without needing to modify them to create multiple copies of the same environments without hitting namespace collisions on these buckets. Another section setting up for the wait handle. Here's where we define the server wait condition. And this would give it a timeout value so that if something did go wrong and hang in one of your processes that are being deployed with CloudFormation, that it would wait a certain amount of time and then time out. During my development, I had this set really high at 2 hours. Now that things are more stable, I would probably shrink this down to 30 minutes, 45 minutes, something much lower. And then finally, for the Chef server example, we have the output section, and this is where it will output the URL of the new Chef server that we built, the key bucket that was automatically created and generated that will be unique for each one of these servers, and also the Chef security group that applies for that Chef server, which is also created unique by CloudFormation with that string appended to the end. So now we've got our CloudFormation template developed. How do we run this? One way we could run this would be using the AWS Console, which is very easy to do. So you could at the end go download the server.cfn and simply come down and say services, CloudFormation, create stack, browse, choose file, choose server.cfn, and give it a name. In this case, working through the slides, the server was Chef 12-server 6. It was the sixth one that I'd stood up. The next section in the console would ask you for those input parameters that we defined in CloudFormation. The first one that I'm going to pass in here is this DevOps role. This is the IAM role that I pre-created ahead of time that would have the permissions needed to create the unique S3 bucket to store privately our Chef validation key. Next is the instance type, M3 extra large. And I chose extra large here. I could have got by with a smaller instance. But when doing a build, if you choose larger instances, things install faster because they have more resources to run. And since this was a temporary environment, I used a larger instance to complete it faster. Next, I selected my key name, AWS hat, key 01. And then the source location, in this example, of course, was wide open. So if you're going to do it from the console, it can get a little tedious to repeatedly put in those same parameters over and over again once you have those roles and your keys defined. So what I prefer to do is work with AWS CLI for this. Here is an example of how I created an add.server script. It's just a wrapper. And inside of it, I'm actually using the AWS CLI to do a CloudFormation create stack with the parameter -- stack name. And in this earlier example, I was defining the Chef server name actually inside my add server script. If you check GitHub, you'll see later I changed that to be an input parameter. So I could just run add server and then space the name of the server and then do that multiple times if I needed to stand up multiple copies and not have to modify the actual add server wrapper script. And here's what it looks like when it runs. You'll notice the same output came when I did the initial run of add server in the beginning from my console shell. And it outputs a JSON object that tells you that stack ID and the ARN for it in AWS. So now we've got our infrastructure as code. We're building our servers as code. Let's use version control. It's very easy. So I'm going to do a git commit here, ChefConf 2015 presentation commit example. And then next thing we do is git push origin master. And now all the code that I just modified would be synced up and up to date in my GitHub repo, which is available again at https://github.com/aws/chefcon2015. Once you have the server building, since this one takes 15 to 20 minutes to build, you could either go to the restroom, grab a cup of coffee, or what I like to do is actually watch things build in real time. So I'll log back in the console, go into the CloudFormation area, and you'll notice how I did a filter here by name and did Chef 12, Server 5, so I could just see this one CloudFormation template. And then I pulled up the events section, and I'm able to see things like create complete, create in progress, etc. to follow the status. When this template creates building Chef Server 12, the in progress status indicator will change to completed. Once the Chef Server 12 is complete building, then we're able to go in here to the output section, check this server URL, click it, log in, and immediately go and change the password. I do have a chef server control command in the installation script for the server that goes ahead and creates a chef-admin user, and the password for that is there in the code, so you can easily go read that. So anybody else pulling down the same templates from GitHub would easily be able to read that. So if you reuse these, let me be very clear, please, I told you, change the passwords. All right, so, and we can do the same sort of thing with the clients. But before we move into that, let's do a check of the live chef server we're building. Let's see if there's any progress here. Yep, we're still in progress here, so we're a little ahead on timing. So you'll notice I have a Chef Server 12, Chef 12 Server 6 here, and I also have a Chef 12 Server 7. I can filter to see just my chef servers, like this, and I can tell that I now have multiple copies of Chef Server running in AWS. Both of these were deployed with the same template. One is complete, and we could go log in that console and see instances via the output section. Boom. And if we go to nodes, you'll see that this instance that I had pre-created several days ago already has a couple nodes under chef management. And this instance is still building, so we'll give it some more time. Aha, thought it was about time to be done. So you'll notice the status has now changed on Chef 12 Server 7. We now have built Chef 12 live at ChefConf. So let's log in and see this new server and immediately change our password before somebody beats me to it. Aha, just slow on my fingers there. All right, and now that I'm in, users, chef admin, change password. All right, and now our new Chef Server 12 installation is up, it's running, and we could add nodes to it. So we'll jump back to our presentation. So how are we going to add nodes? We're going to add them the exact same way using CloudFormation. And what we're going to do is stand up these CloudFormation templates for the clients. And we're going to start with parameters, same type of parameters as the server. I want to ask for a key name to be able to SSH in. Ask for an instance type, so I know what instance size to run for my clients. Defaulting to M3 medium, smaller instance size for the clients. Then we move to the server URL. So for each client, it will need to know which chef server to connect to when we stand these up. So we simply pass that in as a parameter, as an input parameter. We also define the chef security group that was created by the first template, pass it in as a parameter. In our S3 role here, we don't want to use the same access level for clients that we use for the server because it needed to actually create S3 buckets. The clients can be restricted more, so I'm going to use a different role for the S3 role, I'm going to use what I call S3 access that I named and created in the console that just had the ability to get and read from my private bucket. Next, we're going to pass in the chef key bucket name that was created, that unique bucket name created in the first template. And then I'm going to set a default chef client environment, just as an example of how you could create multiple copies of these templates and change them so that they have different environments by default, or just change the environment that you pass in as a parameter. The mappings on the client, again, we're just working in US East 1. So this is the same AMI that I used for the server. It's the same base Red Hat 6.5 image. Moving into the resources section for the client, we set up our security groups for the client, our IAM instance profile, which is the role to run the client as. Then we move into user data, where we use simple techniques to bootstrap the client again. I'm going to simply pull down from S3 a copy of an install chef client script, which is also under version control in the Git repo. I'm going to chmod it and run it while capturing all of the logs. And you'll notice when I run the install chef client script, what I'm actually doing here is I'm passing in the variables here for the chef client script so that it knows which server to connect to, and those variables are coming from our input parameters to the CloudFormation template. And then finally, we define the key name and the instance type for this particular instance. Now, you don't have to create just a single EC2 instance type here. This could instead be an auto-scaling group that had these instances in it, and as it auto-scaled up, it would create new instances and automatically bootstrap those into Chef. And we'll also cover at the end how, as it auto-scales down and nodes go away, I have the client set up in the client configuration script so that it creates an initd file for shutdown run level 0 to use knife to call back home to the Chef server and say, hey, I'm out of here, I'm going away, and then it removes that node out of Chef's management. So how do we actually stand up these clients? Again, we could use the console, and if you just want to play with this once and see it work, go home, download server CFN and client CFN, and just use the console to browse to those files and stand those stacks up, and you'll just be pasting these parameters one time to add a client or two. Not bad way to demo something, but it's also easier to use a client script for this that we can place under version control. So what I did here is I have a default client script, that add.client pattern, and I'm simply going to copy it every time I add a new server to a different add client script, such as add client 5 in this case. And what I'm going to paste into the parameter section will be the outputs from server 5 to match for this client configuration. So for the parameter server URL for client 5, I passed in the HTTPS URL for our EC2 instance for that Chef server. And I also paste in the parameter values for for the Chef key bucket that's unique, and also for the Chef security group, which is unique for the clients. And also went ahead, it's not version control if you don't commit it, so I went ahead and committed these examples and pushed those up to GitHub. Now it becomes a simple matter to create multiple clients of just rerunning the exact same script and passing in a different argument. So be thinking CI/CD pipelines here, be thinking Jenkins, et cetera, and how you could use these things from Jenkins jobs to use the same template under version control that doesn't need to be changed to create different dynamic environments. So first thing I do is I run add client 5, and I'm going to use a unique naming convention of server 5-client 1. And what this enables me to do in the console is just go search for server 5 or server 6 or server 7 later, and it'll pull up not only the Chef server but also the clients because of that common string in the name. Once the clients are running, we can just kick back and watch these run and create in CloudFormation. And once they're completed, you'll see that the status for each will change to complete. And then we can watch as the clients show up in Chef Server 12 Web Manager. And this is the cool part, when you're sitting there hitting refresh and hoping things work, and then just suddenly things show up. So let's kick over and actually do this. So the first thing I'm going to do is grab my new Chef Server's URL, make sure I'm on Chef Server 12, outputs. I'm going to copy my empty add client script to add client 7. I want to paste in the server URL. I want to grab the chef key bucket for server 7. Paste it in. And our unique security group for this chef server. Save my file. Add client 7, server 7 dash client 1. And this will build and install Chef client on this EC2 instance and have it automatically bootstrap into our server. We can add multiple clients easily just by changing the number on the name, on the end of the name that we're building. Client 2, client 3, client 4, and let's do 5. 5, client 5. So while these are building in the background, we'll switch back over here to our slides. And then we'll come back to the live Chef Manager in a few minutes. We'll click refresh in there in nodes, and we should see 5 new nodes that have been added. So another great thing about CloudFormation and using it to work with your different dev and test and CI/CD pipelines is that it's very easy to tear down and remove everything that you just built. So the teardown is fully automated. It's handled by CloudFormation. It'll basically rewind everything that it built for you. It deletes those resources. It does a complete teardown on them so that the entire stacks then become disposable objects. For this Chef Server 12 example, I'm going to delete clients in CloudFormation, and then we'll go in the console, click delete on them, and we'll watch as those clients automatically are deregistered from Chef and then removed from the Chef Web Manager interface after they're gone from EC2. So tearing down Chef Server via CloudFormation becomes a simple matter of browsing to the CloudFormation of services, CloudFormation, and then selecting the server that you want to delete, and then clicking delete stack. In this case, the slide was captured when I deleted the first server that I built, chef12-server. And then while it's deleting, you can also watch the progress in the console through services, CloudFormation there. And then when it's completed, it'll simply vanish, and all those AWS resources are gone. You're no longer paying for them, which is what we see here. It's completely gone now. That Chef server is gone, and now we're left with Chef 12 server 3, Chef 12 server 4, and Chef 12 server 5. The clients are just as easy to clean up. You could automate all this through scripting, of course, through the AWS CLI, or you could simply go in when you need to kill a client, go in, browse to the CloudFormation window, search for that client name, and delete that stack. So it's very easy to tear down both in AWS. You could, of course, delete the clients and the servers at exactly the same time. You don't have to do this with the clients first and the server next. You can go in and select all the stacks related to a particular cluster. For instance, I searched for server 3 here, which brought up Chef 12 server 3 and server 3 client 1 and server 3 client 3. Client 2 had been deleted in the previous step, and then I deleted those. So the example code for all of this is available at the following link on GitHub/AWS/ChefCon 2015. And you're welcome to try all of this code out yourself. So let's jump over to our live demo and see how we're going. So when I hit refresh there, I got a little scared. I didn't see any clients. But it is a live demo. I just forgot to change my search string here to server 7. Now we're filtering just server 7. And we can see Chef 12 server 7, client 1s through 5. And when the client CloudFormation script, there is no wait condition set up in there. I only put the example in the server script. So it'll actually return to the console. I just wanted to demonstrate that. It will return faster as a create complete before they show up in the web manager because I didn't use that wait condition. You could go back in and add that wait condition, and they won't show up in the web manager until they show completed in the console. So let's flip back to our brand new Chef Server 12 deployment. Let's click refresh on the nodes, And voila, it worked. We now have 5 brand new Chef clients. And let's select one of these. And you'll notice that it is a Red Hat server. It has the private IP address in our VPC of 172.31.28.216. And it's also showing the public address for the EC2 instance. And the way I got this to show up in the web manager is in the client installation script. The Chef client RPMs depend on the hostname value returned from the system for this field, and it was showing up blank in the interface. So I modified my script to curl the hypervisor from the instance to find out the public URL for that instance. And then I had it set the hostname, use the hostname command to set the FQDN through the output of that curl statement. And then when the Chef server client RPM ran, because that was done first, it was able to determine the host name. And this really helped going through development because I could check the console, see not only the instance ID, but the public ID, and then I could jump in and look at any problems I might have had with the cookbook's run list. For this example, very simple. I seeded the Chef server via knife with the AWS cookbook, and in the run list for the clients that's in the CFN, if you look at the script for it when it sets it up, I'm only running the AWS cookbook and it's not doing anything. So when the Chef client runs, it says, is the cookbook there? Yes, but what it's really doing is it's registering itself to the Chef server. So when that first Chef client run happens and it uses the first boot JSON and it says go run the AWS cookbook, I'm not actually calling a recipe to do anything, but it phones home to the Chef server using the client validation PIM that it fetched from S3, which causes it to register to the Chef server. This is where you can modify these scripts to instead say seed each one of these off of the cookbooks that you have in your Git repos, so that every time you deployed one of these, it was pulling down the latest version of your cookbooks and automatically loading them into the Chef server that you're just going to be temporarily using for development or moving through your build pipeline. So let's tear down some of these and actually see it clean up. We'll flip back over to CloudFormation, and I'm going to delete a client. Notice that status changed in progress. I'm going to delete another client. And let's do 3. That way we should be left with 2 servers when it completes. 2 clients. All right. And we'll give this a second here. It's also interesting to note that you can go to each instance and actually look at the logs while these things build. So if you were to, you could come in and find each instance ID, for instance, in the resource section. It's easy to find the instance ID for each one of these. And then you could look those up in the EC2 console or via the APIs, and then SSH into that instance. And then you can go in, there's a log under var log for cloud init. So if anything goes wrong with the user data, I've got disable rollback in the scripts as part of my development process. I didn't want it to automatically delete the stacks on failure. I wanted it to just leave them there if something was wrong, and then I could go in and look and see what failed. That's also very handy as you work through your recipes or your scripts there. So I see at least 1 client has vanished from the console, 2 clients, and now all 3 of the clients we just deleted are gone from AWS Console. So imagine that we had this instead in an auto-scale group, and we had scaled up to 5 EC2 instances, and now we've scaled back down. One of the common problems that I hear is, how do we get those no longer existing instances back out of Chef? So let's check the web manager here and see if our automation took care of that for us, which it did. And now we're down to 2 Chef clients in our brand new Chef server. So with that, I am at the end of my presentation. And I will say thank you. Have fun with it. And leave the code up. I won't be able to answer any direct questions here on stage because we're running short on time, but I'll be available here with Randall on the side. If you've got any questions, feel free to come over and give us a chat. Thank you.